So yesterday it was an introduction to networking, and we saw that there are few devices very important to know in order to secure network. If someone do not know what network is, then I don't think it is practically possible for someone to protect the network. So understanding networking is what we are trying to do. We are going to learn a lot of protocols that contributes networking, and there is a procedure. There is a sequence in in preparing the packets, in delivering the packets. So all those things, we're going to see little by little. Today, our focus is going to be on addresses. There are various type of addresses in networking. One address is never changing. We call it as MAC address. Whether it is a router or a switch or a computer, there's going to be a MAC address always. Do we have MAC address for a router? Yes, we do. Every port will have a unique MAC address on a router. In a switch, for the entire switch, you will have one MAC address. But on a router, every port, every single port will have a MAC address. Media access control or MAC address. We learned it is 48-bit size binary. The other address is the IP address, which is 32-bit size. And we know the version, it is 4. From the day when we got introduced to the network, it is only IPv4. There is no IPv3, v2, v1. It's v4. The version that became standard is version 4, which is 32-bit. We also have IPv6, which is 128 bits. The reason why IPv6, we are not having enough address space in IPv4. Plus, the protocol IP itself is old. The protocol IP, Internet Protocol, the structure is old. Old technology. That's one reason, old technology. What do I mean by old technology? The IPv4 headers, the headers in IPv4, the header has got a lot of field. Not every field is utilized all the time. Few of them are utilized all the time, and most of them are utilized in various scenarios, but not all the time. So IPv4, the address space is small, the headers are too big, too many fields. So there is need for a change. We want an extendable header. We want an extendable header. What does that mean? Whenever we want some field, we will add that field and we'll use that field. We call it as extendable header, which is not seen in IPv4. Let's say in India, that goods train, no? The goods train, they are extendable. Whenever you have some charcoal or something to carry, you hook it to the engine. I have a charcoal of 3 box. So I'll hook only 3 box to the engine, the railway engine, the goods engine. And whenever I have 6 box of charcoal to carry, I'll hook only 6 boxes, not more than that. That is IPv6 extendable header. The fields are extendable, a kind of plug and play. Whenever you want, you plug it and you will be able to use the field. When you don't want, the field won't be there in the header. Whereas in IPv4, the goods train, the goods engine, that railway engine has got all 50 boxes. Even though there is nothing to carry, it is hooked up into the engine and it carries all the time. Very seldom few boxes are getting filled, because today roadway has become more sophisticated. People transport through roadways. They stopped using railways. So very rarely few people uses that goods train. That 50 boxes in which 1 or 2 boxes gets filled. What about the other 48 box? Hooked up. Engine pulls them all the time. Even when it is empty, you will not be able to unhook. That is what IPv4 header is. It cannot be removed and added. It cannot be detached and attached. The fields in the headers are permanent. Whether you like it or not, whether you use it or not, those fields will be there. And inside the fields, the bits will be there. Because you are not using, there will be some garbage bits, garbage values. And routers that receives the packet process every single garbage bits in every field of the header. So process consumption, time consumption, everything is high in IPv4. Same like what you have in a goods train. If the goods train, even though there is no luggage to carry, if all the 50 boxes are hooked up, you see how long it will take for the goods train to pass the main road. Long time. You need to wait for the gate to open. Instead, if the engine is hooked up only with those 2 boxes of luggage and remaining 48 is no more hooked up, connected up, it won't take much time for the train to pass. The railway gate will be opened very soon for you to use the road. See, IPv6 header is an extendable header, simplified header. Whatever is necessary, only those fields will be seen in IPv6 header. Not only that, when I speak about security perspective, if I speak from security perspective, if I want to have IPsec tunnels, I have provision in IPv6 header itself. I can, because it's an extendable header, I can attach the IPsec field to the IPv6 header. I can attach the IPv6 fields inside the IPv6 header. Whereas in IPv4, you cannot do that. You need an additional layer of IKE. What is IKE? Santosh, any idea what is IKE?
No, sir. No idea.
Internet Key Exchange. That is what IPsec will use the header called IKE or AES, more precisely AES. All right.
What is AE, sir?
It's an encryption
AES.
protocol. AES, triple des, des. All right. When we go to IPsec, we will talk about that. But what I'm trying to say here is, whenever you enable some security protocols, IPv4 cannot accommodate. You will have a separate layer. Whereas in IPv6, you can attach a field where IPsec can be carried. Sorry, I said AES, no? AES is encryption protocol. I mean ESP header, ESP, encapsulation security payload. That is what actually I mean. ESP. In IPv4, you will have additional layer called ESP, encapsulation security payload for VPN. Whereas in IPv6, you don't need this header, a separate header. Inside the IPv6 header itself, you can add one field to carry these informations. So what I'm trying to say here is IPv6 in many ways better than IPv4. Not only size, mostly people will say, why do we go to IPv6? They will say, we don't have enough IPv4. What to do? On those days, they did not think well. And they made 32-bit as a standard. See now, because of them, we are suffering. We are not having enough IP address, you see. Those people are not that clever like me. They did only 32-bit. If I am there, I would have said 900-bit. That's how people will only talk about size of the address. When you talk about IPv6, they will only say, IPv6 is bigger, IPv4 is smaller, IPv4 is 32-bit, IPv6 128-bit. No, don't stop there. I agree, yes, that is true. IPv6 is 128-bit size, bigger than IPv4. But there are many more other wonderful stuff in IPv6 which is not there in IPv4. One of that I have just explained, extendable header. Extendable header, simplified header. Whatever is necessary, only those fields will be seen. Let me show you a picture. You see, IPv6, how many fields you see? You can easily count 1, 2, 3, 4, 5, 6, 7, 8 field only. 8 field only. But you see there in IPv4 how many fields you have. So the size of IPv4 is bigger than IPv6 here. Picture looks bigger here because the source field is big. Don't compare like that. Actually, IPv6 header is simplified header, smaller. All right, so actually this is two fielded. You can finish it like this. Small header, that's all. All right. Even though IPv6 header, IPv6 address is 128-bit source address, 128-bit destination address, here it is only 32-bit, 32. Even though the address size is bigger, the total header size is many times smaller than IPv4. You see this optional field, who knows what is inside, how many bits they are going to carry, padding, no limit. But here, everything is well determined. You know what it is going to be, the size of IPv6 header is going to be when you add some feature. A new header will be getting, say for example, I'm adding IPsec, then a small header is going to be added, and I'll know what will be my header size. So IPv6 header is simplified header. Only when you have some routing protocol, I will add that field to IPv6. Whereas in IPv4, always this field will be there whether you use it or not. Yeah, though we do fragment or not, fragment offset fields will be there. A lot of things. So I don't want to get into the headers now. We will see those things by capturing some packet in a live network later. Now, I'm not focusing on IPv6 in depth. I'm just trying to give the address types that you see in networking world. IPv6 is 128-bit, bigger in size. Now, apart from this, we also.
Brother, one doubt. Is IPv6 already in use, or is it going to be
Okay,
used in future?
it's a good question. Now, let me give you one live. IPv6 migration is already started. IPv6 will be deployed without your permission. They don't need your permission to migrate you to IPv6 from v4. IPv6 migration started many years before, but in 2024, Jan 1, US have started explicitly, many companies from US have asked for this migration strategy training from IPv4 to IPv6, especially this last year, December till today, many requirement, which means government is directly or indirectly forcing it. IPv6 already deployed in big ISPs like Vodafone. I was there in Netherlands, Herlen, a place called Herlen, teaching IPv6 migration for Vodafone few years back. Few years back, not last month or last year. So migrating from 4 to 6 already done in most of the core networks. It's already done in most of the core networks. Migration is done. Only the end users like you and me still not added to the IPv6. Again, I'm telling you, for that, without your knowledge also, you will be inside IPv6 one fine day. Because your operating system is already enabled to support IPv6. And your routers and your PCs will get an IP address via DHCP from the ISP. So when ISP gives IPv6 address, your laptop will get IPv6 address. And you will not know that. Right? So, and then services of IPv4 will be stopped. Even if you want to go back to IPv4, you will not, you will think that why should I go for IPv4? There is nothing in IPv4 because everyone stopped the service. Nothing, no services in IPv4. Earlier, when I was trying with IPv4, I was able to download the Windows update. But today, I'm not getting any update. But when I try with IPv6, then I get the update, which means they have stopped IPv4 service. So the entire world will just like turning on the switch, which is off now. They will turn on, and then all will be in IPv6. 1 hour in 1 minute. So IPv6 is already there. End users will be moved to IPv6 seamlessly, and then you will when you try to troubleshoot something, then you will end up in seeing an IPv6 address in your computer. I have seen in many companies already IPv6 and IPv4 both present. We call it as dual stack. So some of the customers may be in IPv6 already. Some of the branch office may be in IPv4. So now you can talk both to branch office which has got IPv6 as well as the branch office that has got IPv4. We have this type of dual stack during this migration period. So answer to your question is yes, IPv6 is already there. It's not yet to come. It is already there. And this year, 2024, it is more speed. Earlier, it was only focused in the core. Now it is even deployed in the perimeter of the network between the customer and the service provider. So very soon, who knows, by the end of April or by the end of December in this year, we will all be in IPv6. Now is the time for IPv6. Any other question? Okay, if no question, there is also another address kind of ID called port number. Yesterday, Santosh was asking about this port number. Port number is also a kind of ID only, address only, that helps to address, that helps to locate a service in a device. Port numbers. Port number 2021 FTP. TCP port number. Port number 22 SSH. So when I say 22, it addresses what? It locates what? SSH service. Port number 23. What is port number 23 TCP? Santosh, what is port number 23? Telnet. Telnet. Port number 80 HTTP. What is port number 443? HTTPS. Now, these are all widely used services. That's why I'm writing them. And I'll also write one in UDP. UDP 52. Anyone knows what is UDP 52? Very often this UDP 52 is used. What service uses UDP 52? I'll give you a clue. For going online without UDP 52, it is not possible. If you want to log into Facebook or if you want to log into YouTube, you need UDP. Santosh.
I have no idea.
Okay.
I don't know.
DNS? DNS. DNS.
Is it TCP?
DNS.
Yes.
Sorry, it's 53. I was asking wrong. That's why you didn't answer. I know if I would have said 53, you would have said DNS. Okay, domain name server. which resolves the domain name into IP address. So these are all very frequently used port numbers we should remember. Few more things I'll let you know while we learn more things. So according to me, this is also a kind of address. Now, apart from these addresses, there are also many other addresses. For example, to identify a device, a computer's BIOS, there's something called UUID. There is an address called UUID for your laptop, for my laptop, for everyone's laptop. There is one unique UUID. But it's not that important. If you're getting into data center domain, you need this. And if you're into data center domain, then you need more things like WWPN address, WWNN address, worldwide port name, worldwide node name. These are all these two are FC related, fiber channel related. Let's not get into that. I'm just giving you, there are many addresses we will come across in networking world. So if you find somewhere WWNN, WWPN, don't wonder, that's also a part of address. That is also to identify the storage devices in data center. Now, we know that size of IP address is 32-bit. And this 32-bit, for our convenience, it is broken down into 4 octet. So 8-bit is 1 octet, 4 octet, 8 multiplied by 4, 32 bits, binary. Now, because it is only 32-bit, for the entire world, we need to provide connectivity with this 32-bit. So it needs to be utilized very wisely, properly. So what they did is they did some classification. Class A, B, and C. We also have 2 more classes. But this D, class D, is to identify a group. We call it as multicast range of address, multicast. So you cannot assign a class D address to an individual port for an individual computer. That's to identify many devices in a group. When we learn multicasting, you will understand how multicast address can be used. We'll be learning multicasting later. Class E is still research and development. Not yet decided it. That's what. But we are already in IPv6. You don't need to worry about class E too much. So the 3 classes that you need to focus is A, B, and C. Don't worry about D now. When we go to multicasting, we'll talk about D later. Focus only on these 3 classes. Anyone knows the range of class A, B, and C? In class A, the first octet out of 4 octets, the first octet alone is networking. One octet is 8-bit. In class A, only the first 8-bit is network. In class B, first and second octet is network. In class C, the first, second, and third octet is network. To identify a network, see, when you take an IP address, I know that this is a 10 network first computer. This computer is in a network called 10, and in the 10 network there may be many computers. So in the 10 network, this is the 001 computer. This is 002 computer. That's the host ID. Host, host, host. There's 3 octets you see here. The first octet represents network. So when you have an IP address, you will know both the network to which this computer belongs to, and also in that network, what's the ID given to this computer. So there is a host portion, there is a network portion in each address, IP address. Even in IPv6, the same story, but you don't have classes in IPv6. I do not want to get into too much of IPv6 today. That's a separate topic. We'll keep it for another day. This is a kind of revision. You may already know this, but I want to make sure you know this. I want you to recall those things that you learned in your past, the IPv4 stuff. So we are here. If you notice here, Class A has got more host. Class C has got very less host, only 8-bit. Whereas here, 8 plus 8 plus 8, 24-bit. Whereas here, it is 16-bit. So what do you understand from here? They have classified so that there won't be wastage of IP address. For those who need lakhs of IP address in a network, Class A will be given. For those who need only few hundred, maybe 150 IP address in a network, Class C will be given. So if I will give a Class A address for someone who needs only 150 IP address, then I'm wasting a lot of address. I can say lakhs of address you will waste. If you are going to give a Class A address for someone who needs only 150 IP. So classification helps us to identify the group's size and provide address from this class. For a large size company where there are lakhs of computers and tens and hundreds of departments, Class A will be the suitable address. Now in Class A, ranging from 1 to 127 in the first octet is Class A. If you will find an address starting with 192.168.5.4, this is not Class A. Why? This 192 is not in between this. When you see an address like 116.200.172.10, don't see these numbers, only see the first number. It is in between this range, so this is Class A address. If this is Class A address, how do you read this? It is 116th network, 200.172.10th host. That's how we read this. This is the host portion, this is the network portion. Class A address. So I just said that we read this address as 116th network, 200.172.10th host in that network. That is why we write subnet mask like this, 255.0.0.0, which means the 8-bit that you have here is what indirectly said 255. 255 is the face value of all 8-bit. If you turn on all the 8 bits and convert it into decimal, you'll get 255. So this means that this portion is the network, all the remaining portion is host. We call this as subnet mask. So with the help of subnet mask also, you will know which octet is network and the rest are host. So when I see 255, I can understand that only this 8-bit, this octet is network. These are all not network, they represent host. So the default mask for class A is 255.0.0.0. That is what called a subnet mask. Subnet mask tells you how many bits were given for networking. In class A, only 8-bit is given. So the mask will be 255.0.0.0. For class B, two 8 bits are given, 8 plus 8. So it is 255.255.0.0. So when I see an address, when I see an address 172.16.10.1, I'll very clearly know that this is the network portion and this is the host portion. 172.16th network, in that network, this is 10.1th computer. How do I know? Because the mask for class B is 255.255, which means only these two octets are network. So subnet mask represents the number of bits that were given for networking. In class B, two octets are given, so the mask is 255.255. In class C, three octets are given, so the mask is going to be 255.255.255.0. For example, 200.0.1.1. So when I see this, I can understand this is class C. If it is class C, these three octets are network, and this is the host portion. And these are the range you should memorize, if possible, memorize. 1 to 127. Actually, it is 126. 127 is dedicated for self-diagnostic test using loop back function. We'll talk about that after a few minutes. So class A has got only 1 to 126. 127 is not A or B or C. B is 128 to 191. C is 192 to 223. How they got this range? Actually, that is a waste of time. But still, if you are willing to learn that, I can teach you if you'll ask. The range is 1 to 126, 128 to 191, and 192 to 223. For class D, The range is 224 to 239. Again, class D is not a valid IP address. It is to identify group of device. It is a multicast address. So let us not get into that. Do you have any question on A, B, and C, please? All right.
Yeah, clear, brother.
Mhm.
Sir, for the class A, if you give a limited amount of IP addresses, will there be any consequences like
Can you put the
will
question
there
in
be any
Tamil?
negative consequences in class A? சார் இப்போ வந்து
Hmm.
150 ஐபி அட்ரஸ் நம்ம கிளாஸ் ஏக்கு நம்ம கொடுத்தோம் அப்படின்னா
Okay, right.
அதுல வந்து
ஒரு
கான்சிக்வன்சஸ் என்ன
கிளாஸ் ஏ
நம்ம கம்மியா
நெட்வொர்க்
கொடுக்கறனால என்ன
எடுத்துக்கிட்டீங்கன்னா
கான்சிக்வன்சஸ்
உதாரணத்துக்கு
இருக்கும் அப்படின்றத
11 டாட் பாருங்க 1ல இருந்து 126க்கு நடுவுல தான் 11 ஒரு நம்பர் இருக்கு. If you take that 11 network, you can have 2 to the power of 24. See, you got 24 bit, 8 plus 8 plus 8. So it is binary. So 2 to the power of 24 minus 2. That will be millions of IP address that can produce. 11 network can provide you millions of IP address. But when you have given this 11 network to a group which needs only 150 IP address, then what happens to other addresses in that 11 network? No one can use because 11 network is sold to you and no others can claim that. Though you are, even though you are not using it, it's yours, given to you. You used only 150, but 2 to the power of 24, it's big number. This many million, 16 million plus. But you are going to use only 150. So 6 million plus IP addresses are unused, cannot be used by others as well. We got only 32 bit for the entire world, in which you have wasted 16 million, which could have been utilized for various countries to provide international services, something like that. So, see, there won't be any impact. 16 million பயன்படுத்த வேண்டிய இடத்துல 150 பயன்படுத்தினா நஷ்டம் இருக்கும். ஆனா நெட்வொர்க்கிங்ல ஒரு பெரிய இம்பாக்ட் வராது. என்ன மாதிரி இம்பாக்ட் வரும்? நிறைய பேருக்கு ஐபிஎஸ் கிடையாது. அவங்களால நெட்வொர்க்கிங்ல பார்ட்டிசிபேட் பண்ண முடியாது. அவ்வளவுதான். வேற எந்த மாதிரி இம்பாக்ட் வராது. கொஸ்டின். Okay.
Okay,
So,
sir. Okay.
is anyone interested in learning how we got this range? Only if you are interested, I'll take, because it is not that important. But if you feel like, I want to know, for me, I think it is good to know. If you will say that, I can tell you how they got this number. See, it's not a round number 190. Why it is 191? Why it is 223? Why it is hanging like 126? How they got this range? If you are really curious to know this, you can ask me. If you say no, we are good, then I can go to the next one. What do you say? Okay, let's learn. You
Yeah,
see,
tell us, brother.
Yes.
we got 8-bit. So they want to classify, and they come up with this idea. What they did is they made this bit as constant for class A. What is constant? It will be always remaining 0. It will not turn into 1. Now, the smallest, if you take this is the smallest, 1. That's why I started with 1. First network. And then the biggest one, if you see, if you see these bits when it is turned on, then you get 127. This is the biggest one. There is nothing more because this is constant. You can't make this as 1. This remains 0 always. When you make all these bits 1, the value that you will get is 127. How? 2 to the power of 0 is 1. Anything power 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. But because this is 0, 0 multiplied by 128 is 0 only. 1 multiplied by 64 is 64. 1 multiplied by 32 is 30. So you add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get 127. I told you in that 127, only up to 126 is class A, because 127 is dedicated as a loop back address. We'll talk about that in a few minutes after this topic. So this is how they derived class A, 1 to 127. Now let's see how they derived class, how they come up with class B. Class B, I told you the range is from 128 to 191. What they did is, for class B, they made 1 0 as constant, meaning you cannot change that 1 into 0 and 0 into 1. They are constant. Now, when all these bits are 0, you still have value. What is that? 2 to the power of 7 is what? 128. Multiplied by 1 is 128. So you start with 128. That's the minimum. And what is the maximum that you can have? Make all this 1. When all these are 1, when all the 8 bits are 1, you get 255. Now minus 64. What is 255 minus 64? 191. All right. When all the bits are on, 255. If you don't know, please let me know. I'll explain you how it is 255. It's simple. 128 plus 64 plus 32 plus 16. You add all this, you'll get 255. When all the 8 bits are on, it is 255. But because this bit is off, I need to subtract 64 from 255. I get 191. That's how class B range is derived. For class C, what they did is, one one zero as constant. So the minimum, if you take these two are on, that's the minimum. It is 128 plus 64, which is 192. Because only these two bits are on. 128 plus 64 is 192. That's the minimum. What's the maximum? Turn on these bits other than the constant bits. When you turn on these bits, what do you get? 192 plus these things. Or in a simple way, if you need to do 255 minus, what is the value of this place? 32, which is 223. 255 minus 32 is 223. That is class C range, class B range, class A range. Now you know how they might have derived that multicast range. You already got a clue. Simple. They moved one more bit here. And they moved the 0 to the right. Oh, I should have deleted. Okay. 110. Now when this is the minimum. What is the value of these 3 bit? 128 plus 64 plus 32 is 224. Till what's the maximum? 255 minus 16. What do you get? 236. Is it 236 or 239? 239. 255 minus 16. 239. This is what called as class D range or multicast range. Any question? Did you understand how they got the range, Sandosh? All right. Now let us move on to that loopback address. Loopback
Yes, sir. Yes.
interface is different. Loopback address is different. See, on the routers, we create a virtual interface called loopback interface. The address that we put under that interface is not loopback address. It is loopback interface address. That can be even 10.0.0.1. Under the interface, you can, it's a virtual interface, you can give any IP address. Don't call this as a loopback address. This is an address to identify a virtual interface. But when you say loopback address, it precisely says the address that begins with 127. Loopback address is an address which is used as a self-diagnostic, which is used for self-diagnostic test. Your routers, your PCs, or any network device, to check whether the device is ready for communication over the internet, we use this address. Listen, when I go to command prompt and ping 127, give me any 4 numbers. Give me 4 numbers. 127 dot, give me some number, please. 0 dot 1.40. Listen, I have never configured.
0 dot.
First of all, you cannot configure
1
any
dot
computer with address beginning in 127, beginning with 127. Then who is replying me? There is no computer, no device in my network with this IP address. Who is replying? I'm getting reply. Now I ping 127, a random number, 40.56.200. Again, someone is replying me. Who is this? Who is replying me? Why he is replying me? What is the message? What is the message that it is conveying me? Why should they have something like this? You see, The entire 127, we saw there are 16 million address can be derived from one class A address. With this 127, I can have 16 million IP address. One among the address is 127.40.56.200. Another one is 127.0.0. You can have like this 16 million plus. What is this addresses? You type anything starting with 127, you will get reply. 127.111.2222.133, you'll get reply from that same number. Who is this replying me? See, every operating system on earth, it may be Cisco's operating system or Windows or Linux, they all abided to a rule. They all abided there. They follow a standard. In that standard, they said 127 is a loopback address. The entire range means the 127 complete is given for loopback. So when someone is trying to ping with 127 blah blah blah, operating system should immediately go and check whether the system has got proper network driver, network interface card. Only when you have network interface card, you will have MAC address for your computer. Without a MAC address, can you communicate to network? Without a network driver, can you communicate to an internet? No. So immediately your operating system will check these things. As soon as you put 127, blah, 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 operating system understands that you are asking the operating system to check whether the laptop is eligible, ready to communicate. If you don't get the reply, when you don't get reply, I ping 127 some number. If I don't get reply, I need to troubleshoot my laptop first. Before calling the ISP and shouting at him, we need to fix the problem in our laptop. When you don't get reply, there is some driver issue, or there may be a NIC card problem, or your Wi-Fi is turned on. You may not be having a physical NIC card. You want to you always communicate through Wi-Fi, but the Wi-Fi is turned off. If your Wi-Fi is turned off, the data link layer, the physical layer, they don't work. There is no MAC address for your computer. So this is a diagnostic. This helps to diagnose your computer, whether it is eligible, ready to be part of network. So actually, they made the mistake by giving the entire 127 for this single purpose. In IPv6, they have not done this mistake. In IPv6, you see, just one address, ping : 1. That's all. This is what loopback address in IPv6. You see, : 1. I get reply from : 1. I get reply. In IPv6, they have not wasted. But in IPv4, anything that starts with 127, that's too much. 16 million for one single self-diagnostic test is too much. That's not good. See, here also I sent 4 packet and I received 4 packet. I finished my diagnostic test. Why millions of address they wasted? Now we cannot regret because that is gone. We have IPv6 now. So very soon this will vanish. We cannot do any changes once it has become standard. You cannot go and change. The entire world operating system follows the standard. So 127 means loopback cannot be assigned to a computer. You try assigning this IP address to a computer, it won't accept. When you say okay after giving IP address, it will say no, sorry, I cannot accept this. This is not a unicast address. It's a loopback address. Even though it comes under class A, it is not class A or B or C. It's loopback address. Any question? Okay. Santosh, no question? There is another address called
Okay.
APIPA. APIPA.
No, sir. No, sir.
This is also not a valid address. 169.254.blah. You will not see any address starting with this in a computer. What for this? Actually, this is one of the network in class B, isn't it? 169 is here, class B. But that range, that 169.254, like 127 is given for loopback, 169.254 is given for service called APIPA, automatic, private. We know what is IP, Internet Protocol. We know what is a address. Internet Protocol address, only the thing you need to remember is automatic private. It's not public, it's a private, and it comes automatically to convey you a message. I told you this is not a valid IP address. And we see in the name, it is very clearly said that this address is automatically coming, not using DHCP, not because you configured. It is coming automatically. Who gives that automatically? Operating system on the router, on the computer, on the laptop, or whatever the device. That operating system, because it is designed with a standard, every device on earth, every operating system, whether it is Linux or Windows or Mac or Ubuntu, they will generate this address to convey you a message. What is the message? The message is, I am a client. What client? DHCP client. What does that mean? I depend on a server for an IP address. The client says, I'm a DHCP client. I depend on server for an IP address. Unfortunately, I am not able to see any server. The client tried its best to discover the DHCP server and request an address, but it didn't find a DHCP server. So it generates this address starting with 169.254, and this can be any number. It generates automatically and informs the user that I'm helpless. I don't see any server. I need your help now. That's the message. If you find 169.254, it means you don't have server active. Let me quickly show you that. Okay.
So DHCP
You
server.
can use
Is it a
any
blade server or what type of server is it?
device like a router or
Will you have
a Windows operating system to act as a DHCP server. When we say server, it doesn't need to be a computer with a big CPU and big motherboard, a blade or a rack mount server. It can be a computer, small virtual machine, or in a home we have a domestic router that is also a server. The white color, the domestic router with the two antennas or four antennas that you have is also a server. Whichever serves is a server. This is providing IP address for the computer so that automatically an address can be configured on the computer. It's a service provided by some device. That is a server. It need not to be a router. It need not to be a Windows server. It can be one small domestic dongle. So there is no special, that we used to call the workstations, the server, not that type of server. In general, server means the one which provides service is a server. I can configure a router to be a DHCP server, but it doesn't look like a Dell server, right? So server doesn't mean that server class computers. Yeah, it provides a service, so it's a server. And this receives a service, so it's a client. It receives the IP address from the DHCP server. So we are not getting into DHCP in depth today. My intention is to teach addresses, and we have learned classes in IPv4. We have learned loopback. We have learned APIPA. Now, as the last topic of the day, I'm going to add one more: private address and public address. You see, every office have got hundreds and thousands of computers. You cannot provide 100 IP address to a company or 1,000 IP address to a company because you got just 16 million. You got only 32-bit. How can you provide 1,000 IP address to one particular person, one particular company? Not possible. So they came up with an idea of private address. So for all those 1,000 computers, you will give address from this range 10.0.0.0 or 172.16.0.0, 192.168.0.0 till 10.255.255.255 till 172.31.255.255 till 192.168.255.255. So these range is what called as private range. So for the 1,000 computer in your organization, you may use any one class. No need to worry. If you like to use class A, you can very well use it. I have only 1,000 computers. Why will it be harmful to use a class A which is giving 60 million? No problem. It's a private network, private address. Even if you have 10 computers, you can have that class A private address. That's your wish because it's within your organization. No one is going to stop you in using the 10 network which is from class A. Even if you have two computers, just two computers, you can use the 10 range, no problem, because it's a private range. I will also have 10.0.0.1 in my home. You will also have 10.0.0.1 in your home. It won't conflict because the private addresses will not be exposed to the internet public. Public will have all other address except this addresses. All the rest are considered as public address. So these private addresses are not routable in public. Within your organization, you can communicate using this private. But when you are trying to talk to your remote office, which is in Kuala Lumpur, definitely you need a public identity. So If your company is 1,000 employee, 1,000 computer, in the edge, which connects to the internet, where you can connect to Kuala Lumpur, you will have one or two public IP addresses. That's all. So this 1,000 people, when they try going out, they will drop their private identity and they will take their public identity before going out. We call that as NATing, network address translation. We'll see these things in detail later. What I'm trying to say in short is, instead of giving 1,000 computers to a company, you just give only one address for them to communicate to the internet. In this way, you can save 999 IP address so that you can give it to the entire world. Question, please. Yeah, that is one way of explaining netting. Netting is not always private to
So
public. Sometimes
nothing
we also
is
do it between
converting
private to
private
private.
address into public.
For various reasons. When we go netting, we'll discuss. But most of the time, people do private to public. But that is not the definition of netting. Netting is translation from inside local to inside global, or translating the source address to a mapped address. That's how the definition goes. When we go netting, we'll discuss. But what you said is an example of netting. Translating from private to public is one example. We see that in most of the places. When we say netting, it is most of the places we see in private to public. That's right. Question again? Any other question? Yes, we do private to private also. Say for example, I have a company
So netting
and
private to private,
my
can it be
neighbor
done,
sold
sir?
his
Is it
company.
possible?
My neighbor and me, unfortunately, we have same IP address in both office. Now I purchased the neighbor company and I'm trying to merge with my company. If I merge, what will happen? Conflict will happen because he also has got the same IP address which I have. I'm also having 10, he is also having 10. Now I cannot merge these two companies. So what I'll do, I'll translate my 10 into 172. So when he receives, he will receive as if the traffic is coming from 172.16. You understand? So we do translation between private to private whenever we merge two networks that have got same range. This one example. Any other question? Santosh, do you have any question? Right. We stop.
No, sir. No, sir. No.